Okay, so here we are going to start by the unit 1. So write unit 1, lesson 1. And the lesson, it is atomic structure. Atomic structure. So roughly what we want to know, it is the structure of the atom. We're going to start by the first by the first model. This one we're going to start by Rutherford model. There is other models before Rutherford, but we're going to start by Rutherford model. So big one here, Rutherford model. Rutherford model of the atom. So what is the structure of the atom? Rutherford made some experiments with particles, alpha particles. These alpha particles are nucleus of helium. He bombarded atoms, but not gold. And what he found out? He found out that the atom, it is empty. It is a huge vacuum. In the center of the atom, there is a tiny nucleus that is positive. So the structure of the atom, vacuum. Most of the atom is a vacuum. What is in the atom? Massive, very small nucleus. It is positive. The nucleus is positive, and it is full of protons. What we found in the atoms, protons. And what he found out also, he said, look, there is electrons. These electrons are orbiting the nucleus like planets are orbiting the sun. So all the electrons, they are electrons here. This one are electrons. And the nucleus, it is positive here. And the electrons. And the electrons are orbiting the nucleus. The electrons are orbiting the nucleus. Like planets and the sun. Like planets and orbiting the sun. Like planets, Earth, for example, Mercury, etc. Planets orbiting the sun. So this is his model. But this model has problems. So this model, it explains the experiments that Rutherford did and the experiment that was before him. It explains lots of experiments, but it doesn't explain two problems. So I'm going to write here. So this is the structure of the atom. So I'll write it here, Rutherford. It is the model. This is the model. Now we're going to speak about problems. So I'm going to erase, and you can feel free to stop the video until you finish. Okay. Problems with this model. What is the problems with the model? Problems. Why this model is not correct? Problems. First, the first problem, the electrons are negative. The protons are positive. So the electrons are attracted to the nucleus, and the nucleus is attracted to the electrons. So the electrons are attracted by the nucleus. And there is another thing. Because the electrons are charged, there is a theory, Maxwell theory, electricity, that says if the electron or any charge, it is moving, it must emit light. What we call it, radiation. The electron must radiate. The electron must emit light because it has a charge. And it moves. This is the electricity laws, the electricity laws, or the Maxwell laws. There is Maxwell equations for electricity. They are telling us if the electron is moving, because it is charged, it has to give light. What does it mean? Does it mean that it has to lose energy? By losing energy, the electron must crash on the protons, must crash on the nucleus. The electron, by losing energy, must crash on the nucleus, on the protons. What does it mean? Does it mean that the matter is not stable? What does it mean for the Rutherford's atom is not stable? Rutherford atom is not stable. Rutherford atom is not stable. So this is the first problem. With this problem, with this model for Rutherford, we have first problem. It is the atom. If Rutherford is right, the atom is not stable. What does it mean? Life, it is not here. Earth, it is not here. Nothing here. But we see that the atoms are stable because we are existing here. So this is the first problem of the Rutherford model. The second problem here, it is what we called the spectrum emission, the spectrum, the hydrogen spectrum. What does it mean, spectrum? What does it mean, hydrogen spectrum? We just said that because the electrons are moving, they have to radiate. They must give light. So if we see the Rutherford model, we have a problem here, because when we see, for example, the hydrogen has one proton and has one electron. So the electron is moving. By moving, it has to radiate, it has to give light. But when we see what light it gives only, for example, in the visible spectrum, it gives only 4 colors: violet line, blue violet, blue green, and red. And this is a surprise. Why? Because electron, by losing its energy, for example, say he will drop or he will crash on the proton, he will crash little by little. He will lose energy little by little. By losing energy little by little, so he has to emit all the colors. Okay? So the electron has to emit all the colors if he is moving and he is losing energy little by little, because he has to crash on the nucleus. By crashing on the nucleus, he will crash little by little. He can't crash at once. He has to crash little by little until he crashes on the proton, for example. And therefore, he has to give a continuous spectrum, not discrete. This one, it is discrete. Why discrete? Because we have only 1, 2, 3, 4. By continuous, he has to give all the colors. The hydrogen spectrum. I'm going to write here the hydrogen spectrum in the visible spectrum. A hydrogen emits only 4 colors. Emits only 4 colors. What are these colors? Violet line, violet, blue violet, green, blue green, and red. So what is these colors? We call them discrete colors. So I'm going to erase here. So I'm going to erase everything here. So hydrogen has discrete spectrum spectrum instead of continuous spectrum. Spectrum instead of a continuous spectrum. Okay, but Rutherford Adam is predicting a continuous spectrum. Rutherford Adam predicts a continuous spectrum. So this is the two problems. These two problems are huge. So physicists want to improve the Rutherford model. They said the Rutherford model is not right, it's not correct because it doesn't answer these questions, but it explains lots of other experiments. So it is a model that has that must be improved. So who tried to improve this one? It is Bohr's model. So Niels Bohr in 1913, Niels Bohr he will propose another model. Yeah, I'm going to write it here. Right here, big 2. I'm going to take this one here from here. Put it here. Good. And we're going to put here big 2. Bohrs' model. Bohr. B-O-H-R, not R-H. H-R. Bohrs' model. So roughly what Bohr said, yeah, Rutherford's model is not bad. There's a lot of things that is good. What he said that effectively the atom, it is empty, it is a vacuum, and we have a tiny nucleus, and we have some electrons orbiting around nucleus, but the orbits are not anything. The orbits are specifics. They are not ellipses, like for example in the Rutherford model. They are circular. The orbits are circular. They are orbiting, but these orbits are specifics. The electron cannot be anywhere. It has only some orbits that allow to him, and he is orbiting in this orbits. Once the electron is in these orbits, even if it is charged, even if it is moving, it will not radiate. It will not give. It will not lose energy. This is Rutherford. This is the Bohrs model. So we're going to write Bohrs model first. The electron orbits the nucleus on a circular specific orbits. On those orbits, the electron doesn't radiate, doesn't emit energy, doesn't radiate. This is the first point. This is the second point. Okay, so it is on a specific. Orbit, circular orbits, and once it is on these orbits, it will not radiate. The third postulate, what he says the electrons, yeah, they can change orbits. but once they change orbits, then they will emit radiation. If the electron change orbits by jump orbits by making a jump, it will emit light or absorb light. Emit light, does it mean, what does it mean emitting light? It means that you will lose energy. Emits light by losing energy, or, so I'm going to continue here, so I'm going to erase everything here, or absorbing light by absorbing light, and what does it mean? Gaining energy, by gaining energy. So this is Bohrs model. The Bohrs model, it is telling us there is nucleus, a small nucleus, electrons are orbiting, are moving around the nucleus, but not randomly or not in any way. They have some specific, like for example, as when we have a car, we have specific routes. We have to go, we have roads. The car, I can't, for example, drive a car anywhere on grass. I can, but it is not allowed. So we have routes. The same for the atom. The atom has routes. So the atom for the Bohr, the atom will be, and the electron has routes that we call orbits, and it is on these orbits. When it will change the orbits or the routes, for example, going from one route to another one, it will gain energy or lose energy. And now he said, okay, now I'm going to explain you, I'm going to fix the problems with the Rutherford models. So what is the advantages here? So solving, what problems is solved? Problem solved. Problems solved. Recall that what we said, the first problem of the Rutherford, it is why the electron doesn't crash on the nucleus. He solved this problem because he says they will not crash. Why? Because they are in the specific, they are in the good road. They are in the road, they are in the one of the road, and you will not have to radiate. So the electron will not crash on the nucleus if it is in the specific orbit. It is on the specific, if it is on the specific orbit. It is in the right road, the right road, orbit. The second problem, what we said we have the problem with the hydrogen spectrum. He said, I can explain that, why we have discrete and not continuous. He said, why we have a violet? It is because the violet color, because the electron will jump from the road or the orbit. So I'm going to, this is the orbits. The orbits here, it is 6, 5, 4, 3, 2, and 1. You see them n equal 1, etc. So he said, what's happening? If you see the electron he will jump from the 6th level to 2nd level, he will give energy. What energy he will give? He will give the energy corresponding to the violet color. Violet color, jump, the electron jumps, the electron jumps from 6th level to 2 level. Why we have the color, the other color? Why we have a blue violet? Blue violet is said same. Blue violet. Blue violet because the electron will jump from what? From the 5th level to the 2nd level. That's why it is here. From the 5th level, we'll have this one here. Now, why we have, for example, other color, blue-green? Because it is from the 4 to the 2. And why we have the red? Because it is from the 3 to the 1. From the 3 to the 2. So he explained why we have this discrete colors. So I'm going to write it here: blue, green. It is 4 to 2. And why do we have red? It is from 3 to 2. And the experience confirmed that. Confirmed by the experience. Confirmed. Even the equation, he gave the equation. He gave the equation that managed everything here. And the equation of Rutherford, Bohr was confirmed. Confirmed by experience. So it is a success for Niels Bohr. It was a success. It was a success for Niels Bohr, but I have to summarize because the Niels Bohr, it is very important. So I'm going to summarize what he said. So I'm going to write here how the Jameses are done for Bohr. How the Jameses are done. How the Jameses. I'm not going to write how the Jameses physically, but I'm saying, yeah, when the Jameses occur. When the jam occur. So the Jameses occur. For example, say I have the Jameses occur can occur from a high level to lower level. It can also go from lower level to a high level. Okay, so each time there is a jump, so the energy or the color that will be released will correspond to the difference of energies of the two levels. So I'm going to write it here. If the electron jumps from a high level to a lower level, the energy released, here it is the color, yes, correspond to the difference of the difference of the energies of the two levels. What does it mean? It means that when, for example, the electron jumps from the level 6 to level 2, he will release the difference energy between these two here. For example, he will say the energy that I'm going to release, it will be energy in level 6 minus energy in the level 2. It happened that its energy here corresponds to the color violet. That's why we're going to see the color. It is violet. Now, for example, if I see this is the first jump, for example here, if I jump, for example, from level 5 to level 2, he will release the energy that corresponds to the difference. It happens that this difference energy, it is the energy of the color blue-violet, etc. You understand? Now, it can go the other way. Instead of going from the higher to the lower, it can go also from the lower to the higher. By what? By gaining energy. If we give, for example, the electron, say I have an electron, it is in the level 2. And I'm going to hit him with a light or with a photon that has with a violet photon. I'm going to hit him with violet photon. He will gain energy. This difference energy will put him in the level 6. Why? Because he gains energy that can put him in the level 6. We're going to write it here. If the electron absorbs a photon. A photon, it is light. A photon, light color. A photon, it will jump to the level where the difference of the two levels, where it is and where he goes. This is the two levels. The two levels where he was. It was where it was, and where it goes. The difference of the two levels is equal to the energy absorbed, to the energy of the photon of the light. So this is the rule of Mr. Bohr. Niels Bohr tell us this is how it is working. The electron will radiate. Yeah, he will jump to the lower, or he will gain energy. He will be excited. He will go to a higher level. Good. So this is the Rutherford model. Now, what are the problems with this model? There are also two problems. The first problem, how the jump is made. Everybody told him, okay, Mr. Bohr, we like your model because it is correcting the problems with the Rutherford model, but we have another problem for you. I have an electron here is level 6. He is orbiting. Now he decided to go to the level 2 to give us the color violet. But how will we do that? He has to go all the way. By going all the way, he has to lose energy little by little. So by losing energy little by little, again, we have the problem that he has to radiate all the colors. So the spectrum can't be discrete. He must be continuous. So the first problem, how the jump is done. How the jump physically is done. Physically is done. How it goes from the level 6 to level by skipping level 4, level 5, he has to skip all these ones here. If he passes here, he has to radiate the color that gives from here to here. If he skips here, he has to give the color, etc., because he will lose energy little by little. So this is the first, how the jump physically is done. The spectrum must be the spectrum of Bohrs' model, Bohrs' atom, must be continuous. Must be continuous. So this is the first problem. Second problem. The second problem, his model or his equations are not working for the other atoms. It is only working for the atom who has one electron only. If you have multi-electrons, you can't. For example, I have Mercury here. This is its spectrum. Also, the spectrum of Mercury, it is discrete. Neon, also, its spectrum, it is discrete. But it doesn't follow the rules of Bohrs that jump in, etc. No, we can't explain that. Doesn't explain the spectrum of atoms with more than one electron. More than one electron. So this is two problems, and physicists said again, we made progress. We made the progress. Okay, we made progress, but Bohrs' model must be improved. It is not the correct one because it doesn't explain everything. It must be improved. It explains very well the hydrogen atom. It explains very well, for example, lithium plus, because lithium has only one electron. If you have only one electron, lithium has how many electrons? No, two plus. If we take two electrons, for example, it will explain if the atom or the ion has only one electron, Bohrs' model is good. But if it has more than one electron, it doesn't explain it. So I'm going to stop here. You have to understand very well the two models that we said here, that we studied here, but specifically the Bohrs' model. I'm going to stop here, and in the next video, I'm going to see how physicists solve the Bohrs' problems. Okay, bye.